Hello students, you are welcome to Prepclass tutors. With you again is Mr. Chima, one and only chemistry tutor, who is fond of blasting calculations in chemistry. So students, what's going on? What's going, guys? The videos you have been viewing, how has it been very helpful? Prepclass will always like you to like our comments, like our videos rather, and also do not forget to drop your comments on our comment section box on what you think about our videos, because we want to make sure that what we are presenting to you guys is actually very helpful and very entertaining enough. We want it to be in such a way that what we are doing helps you in blasting all those simple WAEC calculations. Don't mind what they are, just all those things are very simple. Just continue to follow us on our videos, and we'll continue to show you the tricks involved in destroying all these questions. Okay, so quickly today, Mr. Chima is going to be engaging you in WAEC past questions 2020. As you can see, WAEC past questions 2020 on chemistry. So in our previous videos, we have attempted our questions number 1 to 35, I believe so. Questions 1 to 35. So quickly now we'll be looking at questions 36 to 40. Question 36 to 40. So quickly, let us go. Question number 36. Which of the following statements about the solubility of a salt is correct? Which of the following statements about the solubility of a salt is correct? A salt whose solubility increased with temperature would not crystallize easily on cooling. No. A salt whose solubility is independent of temperature will normally crystallize out on cooling. C. Crystallization would be efficient in separating out a salt whose solubility increased considerably with temperature. And D. Solubility of a solid does not affect its solubility of the solid affects its crystallization. The best choice here is option 1, C, because crystallization will always be efficient in separating out a salt whose solubility increases considerably with temperature. You know that solubility of a substance usually depends on temperature. So temperature highly affects the solubility of a substance. Temperature highly affects the solubility of a substance. So once temperature is raised, crystallization will be faster. So the best choice is that crystallization will be efficient enough in separating out a salt whose solubility increased considerably with temperature. So your best answer is number C. Question number 36. How many moles of H2SO4 are there in 50 centimeter cube of 0.108 mole dm cube solution of the acid? How many moles of H2SO4 are there in 50 centimeter cube of 0.108 mole dm cube solution of the acid? They're asking you the number of moles. So if you see here, they've given you the volume and they've given you the molar concentration. So now there's a formula that says that molar concentration, that's a mole per dm cube, is equals to number of moles all over volume. Molar concentration equals number of moles all over volume. Now they've given you the molar concentration. Let me apply a pointer. Okay, now they've given you the molar concentration. This is the molar concentration, which is 0.108 mole, and this is the volume. So they are asking you the number of moles. You just use this formula. Molar concentration equals number of moles over volume. So this is the molar concentration, 0.108 mole. The volume must be in dm cube because the unit for molar concentration is in dm cube. So here, since it is in 50 centimeter cube, you are going to convert this 50 centimeter cube to dm cube. So now centimeter cube to dm cube is what? Divided by 1000. So you are going to say 50 all over 1000, and that's going to give you 0.005 dm cube. So now this is the volume, 50 by 1000, 0.005 dm cube. So this you're now looking for a number of moles. Number of moles is not given. If you look from this formula I gave you, for you to get a number of moles, you can easily cross multiply number of moles times 1 molar concentration times volume. So from there, you know that your number of moles equals your molar concentration times volume. It's very simple. So that becomes this times this will give you 0.0054. So when you convert it to standard form, move the decimal point 3 times. 1, 2, 3. When you move decimal points 3 times to the right, it's going to come in front of what? 5. That becomes 5.4. Because you are moving it to the right, it will be what? Raised to power minus 3. So that's 5.4 times 10 raised to power minus 3 dn cube. I believe you understand this calculation is very simple. So the correct answer is number D, 5.4 times 10 raised to power minus 3 dn cube. Question number 38. If 20 centimeter cube of sodium hydroxide was neutralized by 20 centimeter cube of 0.01 mole dm cube tetra also sulfate 6 acid, what is the concentration of the base? Now, if you look at this formula very well, you know that if you look at this question rather very well, you see that this is a titration question. And in titration question, we use the formula that says CAVA over CBVB equals NA over NB. So before then, you have to write the equation of reaction. They've told you that 20 centimeter cube of sodium hydroxide was neutralized by what? Was neutralized by 20 centimeter cube of 0.01 mole dm cube acid. What is the concentration of the base? So now this is your sodium hydroxide. You have to write the equation of reaction and balance it. Sometimes they may give you the equation of, but in this question they didn't give you any. So it's your job to write the equation of reaction and it's your job to balance it. So NaOH plus H2SO4 will give you Na2SO4 plus H2O. So placing 2 in front of NaOH and placing 2 in this front of H2O will balance the equation. This 2 here, so sodium becomes 2 here, 2 here, balance. Hydrogen here becomes 2 because of these 2. So 2 plus this 2 is 4. Hydrogen is 4 here. That was why I placed a 2 here, so that 2 times 2, 4. Hydrogen is balanced. Oxygen is 2 here because of these 2. And oxygen is how many here? 4 here. That's 6. So here oxygen is 4 plus this 2 in front of hydrogen that's affecting oxygen. That is 6. Oxygen, so sulfur is 1, 1. The equation is balanced. So you now write the mole ratio. You see that 2 moles of NaOH is reacting with 1 mole of H2SO4 to give 1 mole of Na2SO4 and 2 moles of H2O. Now applying your formula CAVA over CBVB equals NA over NB. What is CA? Concentration of the acid, moles per dm cube. What is CB? Concentration of the base. What is VA? Volume of the acid used. What is VB? Volume of the base. So you can see that here CA, concentration of the acid, is 0.01, which is this, because they've told you this tetra also sulfate 6. So you can see that here CA, concentration of the acid, is 0.01. They're giving you here. Concentration of the base is unknown. That is what they ask us to find. Concentration of the base. Volume of the acid is given 20 cm cube, which is this. That's volume of the acid, 20 cm cube. Volume of the base is given 20 cm cube, which is this 20 cm cube of sodium hydroxide. Now the number of moles Na over Nb, number of moles of acid over number of moles of base, is gotten from the equation of reaction, from the mole ratio, which is 2, 1, 2, 1. The acid is what? 2, and the base is what? 1. So that's number of moles of acid 1, number of moles of base 2. So just substitute the value, this times volume of the that is concentration of the acid times volume of the acid, all over concentration of the base, CB times volume of the base, equals the mole ratio 1 over 2. So what do? Here you cross multiply. So 0.1 times 20 times 2, you can see it here, 0.1 times 20 times 2 equals CB times 20 times 1, CB times 20 times 1. Now 0.01 times 20 will give me 0.4. Then CB 20 times 1 will give me 20. So 20 times CB will give me 20 CB. So how do you get your CB? Divide both sides, right? Good. So now divide both sides by 20. So CB becomes 0.4 divided by 20, and your CB becomes 0.02 moles per dm cube. It's very simple. So you just apply that CAVA over CBV equals MA over NB. Very, very simple. Okay, so your answer CB becomes your answer is now your answer, like we said, is CB is 0.02 moles per dm cube. So the correct answer here is B. We got 0.02 moles per dm cube, and I have 0.020. It's the same thing. 0.02 moles, 0.02 is the same thing. So this is the answer. Option B is the correct answer. Okay, question number 39. Electrons always occupy the lowest empty energy level is a statement of. Electrons always occupy the lowest energy level is a statement of. Now what we'll do here now is to write out what each of these principles states. Then we can now relate it with the question. Then from there we can now choose our best answer. Now for the alpha principle states that electrons are fed into orbitals starting at the lowest energy level before filling higher energy level. Hund's rule states that electrons occupy each orbital singly first before pairing takes place. That's Hund's rule. Electrons occupy each orbital singly first before pairing takes place. Then the Pauling exclusion principle, that states that two electrons in the same orbitals of an atom cannot have the same values for all four quantum numbers. Then the periodic law states that the properties of an element are periodic function of the atomic numbers. So if you see all these statements here, you see that the one that is similar to the question, electrons always occupy the lowest empty energy level, is the alpha principle, because alpha principle says that electrons are fed into orbitals starting at the lowest energy level before higher energy level. So you can see this statement saying electrons always occupy lower empty energy level. Electrons always occupy empty energy level. Then alpha states electrons are fed into orbitals starting at the lowest energy level before. So this is the only one that relates with this question. This is the only one that relates with this question, telling us that electrons occupy lower energy level before they climb towards higher energy level. So the best choice is as option number A, alpha principle. Question number 40, and obviously the last for today. Which of the following metals does not react with water to produce hydrogen? Which of the following metals does not react with water to produce hydrogen? Now look at the statement I made here. I said the elements lithium, potassium, and sodium all belong to group 1 elements of the periodic table. So you must understand that lithium, potassium, and sodium all belong to group 1 elements of the periodic table, and that these elements are the most reactive metals. They all react vigorously with cold water to liberate hydrogen. So sodium, lithium, and potassium all belongs to group 1, and those elements in group 1 are very, very reactive. So all of them usually react with cold water to displace hydrogen. But zinc does not belong here. Zinc belongs to the transition metals, and the transition metals do not react with cold water. For them to react with cold water, in most cases, they must be red hot, and what they mostly react with is steam. So zinc cannot react with cold water to liberate hydrogen. So the correct answer there is zinc. So it is zinc that does not react with cold water to produce hydrogen gas. So because of that, the correct answer is what? Zinc. So zinc is the correct answer. Okay, students, with that we've come to the end of today's section on chemistry with Mr. Chima solving WAEC past questions 36 to 40. Now, if you look below here, you are going to see a link. We urge you to use this link to join us on our WhatsApp. So visit this link, click this link to join us on our WhatsApp. So if you join us on WhatsApp, you will always be getting updates. You're getting updates on the latest videos we've posted, videos that will be very, very interesting, videos that you'll find interesting rather, and videos that will be very engaging. The videos you'll be getting will be videos not only on chemistry but on every other subject which you are interested in learning. So we urge you to try as much as possible to click this link and join us on WhatsApp too. So till you meet again, my name still remains Mr. Chima, your prep class tutor on chemistry. Bye and do stay safe.